Welcome to Syntax. Today we have Zack Jackson on the show to talk to us about module federation. I just saw Zack like a week and a half ago at a conference. He's the author of Rspack, which is the Rust-based bundler, has the whole same API as Webpack. It's really neat. And just that one talk, which was 20 minutes long, the super short talk, blew my mind in terms of like all of the stuff he's working on. He works at ByteDance and was explaining ByteDance's company, TikTok and CapCut and all kinds of other neat products, but just explaining the scale of the problems that he's solving. And I just walked away being like, I want to talk to this guy for like 9 hours. But welcome, Zack. Thanks for coming on.
Yeah, thank you for having me.
Give us the introduction of who you are and what you do. I gave a pretty poor one there, but let's hear it from you.
Yeah, sure. So I'm an infrastructure architect at ByteDance. So I work on the web infra team there. I've been in open source space for, past couple of years. So I'm probably more well known from that standpoint. So I'm maintainer of Webpack. I'm part of the core team for Rspack. And I'm the creator of Module Federation. So that's the big highlights.
Awesome. And that's specifically what we wanted to have you on today to talk about, which is what module federation is, because it's one of those words that I've been hearing going around. And then anytime I talk to somebody at a conference that is from a very large company, I always find that very interesting to like, how do you build stuff relatively fast when you have 7 million teams, and all these different builds? And one little thing that you said during your talk was that people are on call for the bundler. Imagine being on call for Webpack. Like you have to be the expert on that. And I was just like, man, that's because it's true. Like what happens if the build is breaking? You can't merge something. That's pretty wild, right?
It's kind of similar like to CI, like you always have like your DevOps, and when CI is down, it's okay, well, there's only like a handful of people in the company who generally deal with it. But when you get, like when things scale up enough, your actual compilation process becomes equally as crippling, I suppose, because not everybody knows how to fix those. They're also another niche area. And then on top of that, the more exotic the applications are, the more like intricate the build process is. So, if you're like trying to bundle, say, a native app and you're like, oh, hey, why is, this one thing not working under this circumstance? Your general dev doesn't know. If it's not like ESM or something, usually devs aren't like, oh yeah, I know how to, handle like a multi-dimensional output build and, what's going on between the threads or other random things like that.
Oh yeah.
So it does end up actually being a large portion of the on-call is just making sure that builds are functioning correctly. And that was one of the reasons why we ended up building Rspack, was to just reduce that pressure.
Wow. So how much web does ByteDance do? Because I know so much of my experience with the products is all native apps. Is how much of it is web?
All of it, even the native apps.
Really?
So the native apps we have a project called Links. We'll be open sourcing it sometime early next year. But Links is essentially our in-house React Native. So all the apps are Links apps. Everything is a Links app. It's all backed off of the same stack. So there's a really good article for like some background info on how the company operates. If you just Google how ByteDance became the world's most valuable startup, it'll be the Harvard Business Review article, should be the first result. But it goes into really good detail on like how the company is structured. And so one of the big things is we call it SSP, which is essentially Shared Services Platform. And so the whole idea behind it is really you have like very tactical specialized teams who focus on only one slice of the overall pie. So you'll have like an algorithm team or a compiler team or a kernel team and so on and so forth. And then when product needs something, you can just go get the algorithm team or you can go get the kernel team and they'll write, modify the runtime that all this stuff runs on. So everything's like really compartmentalized, but it allows for you to have this really kind of like high density skill levels. And yeah, so that's just kind of how like the company is structured, but it gives us a lot of flexibility in terms of like what we need the products to do. And then on the other end, because of SSP, the whole idea is like, how do you have a unified architecture? So what we're maintaining here can be adapted and supported in 100 different ways. But at the end of the day, we have a very consistent stack that's just very porous. But it's not like one giant one size fits all. It's more like, how do you create the sum of parts that are designed to work independently, but when combined, work very effectively together? And so that's kind of the whole idea behind it. We build all these things as standalone parts that happen to lock into place into a bigger product when needed.
Wow. So, because like, if people are thinking, oh, what else is there? There's obviously TikTok, the mobile app, the Android app, but then there's the website, and then there's also the CapCut, which is like a whole blown video editor.
There's Douyin, which is the Chinese version of TikTok. It's the bigger one. There is Pico, the VR gaming headset.
Yeah.
Pico. So we own Pico. There's Mars Code, which is a kind of like Cursor.
What?
Yep. There is Coze, COZE.com, which is like a AI bot builder, workflow builder tool or something.
Man.
I'm trying to think of the other things. CapCut, Lemonade, Lark, Lark. It's like Microsoft Teams, but built better and does more. So that's what everything that we do, other than the IDE, everything that I do at work is inside of Lark. Calendars, booking flights, looking at payroll, requesting time off, writing documentation, Kanban boards for the extent that we have those type of things, chat, email, like everything is in Lark. The only thing that isn't in Lark is the browser and the IDE. Other than that, you basically never leave it. So there's a ton of products, and these are just like a handful that I know, but I know that we have over 1,000.
Wow. That's unreal that there's that much. So talking about module federation, obviously you need to be able to share stuff between it. So what is module federation?
So module federation is essentially the ability to dynamically link parts together at runtime in some kind of a stable way. So there's two versions of federation that came out. There was V1, which was the one that I had PR'd into Webpack back in 2019. So from that perspective, the whole idea was, it kind of started with an obsession probably in like 2017 because I'd started to work in micro-frontends already, but it was the LOSA, LOSA architecture. So lots of small applications, which essentially meant you mount a bunch of apps onto divs in the browser, and each app is kind of your old school traditional micro front end where, it's a whole bunch of little parts. They each have a div, they mount onto the div, and you would, use like externals or something. So everybody needs React. Then, you'd have like the vendor chunk that sits at the top of the page with like React, Redux, Lodash, a few other things. And then all the parts would just hook into that. And that's kind of where I started to see the pain points, so this was when I was working at Fiverr, and we had like an old Rails app that we were modernizing. And so how we did it was micro-frontends. So the whole idea was the Rails app would kind of do a post request of its data, would post it to a render layer, and the render layer would return the head, the foot tags, and then return the markup, and then Rails would render the markup inside of its kind of shell. So the challenge that we started to see with that was, okay, you can use externals, but you have to manually configure it. So if you don't want everybody to duplicate, say, like Lodash, you would have to externalize it. But then if you do, everybody has to be on the same version of Lodash. And what you're developing with locally usually isn't the same versions of the dependencies you actually have in the vendor bundle, because that's shipped from like a different build. The second kind of challenge that you would see as well is with externals, it's synchronous. So that means you have to have a render blocking tag at the top of the page before any of the other apps run. So whether or not I use Lodash doesn't matter. I have to download it every time. And every piece of shared code has to be render blocking and loaded, regardless of if the application's actually using it. So this is where I kind of started to see the pain point. It was really difficult to manage and orchestrate. And how we were doing the render layer as well was everything was an NPM package. And then you would publish the NPM package, and something like Renovate bot would pick it up and automatically open a PR to like the render layer. And you'd have to wait for the bot to open the PR, and you'd merge it. So now when you send a post request with the package name, it knows which thing to render and can send back the correct assets for it. The problem that we ran into with, or that I had run into with this approach was, one, it was really slow. Like everything, what I refer to it as like the double deploy. So let's take an example of, you've got an NPM package. Let's say you have like button, a really small example, but let's just say it's button. And then you have header. and now you want to update button, and you need to update it inside of header. So first you have to pull button, develop on button, push button, release a version for it. Then you have to go pull header, install a button into header, push header, and then finally you can actually see it pop up in the render layer where you have to do another install deploy. So you're looking at like 3 like kind of pings back and forth before you can actually get the product into production. So you end up losing a ton of time just trying to push things through the pipeline of like a normal package-based, or I refer to it as kind of like the install-based delivery pipeline. Most of your time is spent like running around the org. Like at other bigger orgs, same kind of issue. Oh, I want to, let's say it's just header, and you want to roll out header to say 10 or 11 different parts of the org. Maybe you've got like, community content, you have e-commerce, and you have checkout. So then just getting that synchronized that'll take probably 6 hours if it's just you doing it. To go to each team, nag them, wait on their QAs, run it through the pipeline, which takes 30, 40 minutes to actually get it into environment 1, and then after that you got to run it to preview environment, and then finally to get it to production, and you have to do that 3 times over. Plus everybody has a merge queue because there's other things in the product that are also trying to move in.
Oh man, that probably just kills your enthusiasm for
like
stuff.
You can, some days I could go to work and all I would do is just stare at CI and talk to people. Wouldn't actually do any work. It's 10 minutes to fix the typo, and then I'd spend the rest of the day trying to like scrape this thing through the company and actually get it into production. So it's just a huge productivity killer. So back when at Fiverr, the thing that I was not happy with was the latency that it takes to actually get things out. And then secondly, the bloat. It's like, okay, well, I'm downloading so much because the externals doesn't work very well, or I have to do this giant render blocking tag with, 300 kilobytes when I'm only using maybe 50 kilobytes of what's in there. And so the idea had come to me, well, why can't we just dynamically import chunks from a different build? So if I already have React, why can't I just get the code that I don't already have, like the actual feature code for header? I have all their vendors already because I'm a React app as well. But if I don't have Lodash and they need Lodash, why can't they just supply me the things that I don't already have? And so that's essentially the concept of federation. There's 2 parts to it. The first half is the compiler part. And what we do in the compilation step is essentially we say, all right, what are the things that you want to share? The things that if you say, okay, I want to share React, I want to share Redux, Lodash, whatever, we will then split your bundles so that there's a React chunk and a Lodash chunk, and those are separate from like your main bundle. And then so there's exposing and there's sharing. So sharing is cool. Symverse safe, NPM packages. You can say, hey, do I want this to act as a singleton? What version of it do I specify that I need? Similar to how NPM install would work with your package JSON. And then we shard the bundle accordingly. And then there's exposing, which is similar to like package JSON exports field. So where you can say, all right, and I want to expose header to you. So now only what's in the expose or like the exports field can I import on the other end. So the sharing's all like magic under the hood. And then I could say, checkout/cart. And then they would have exposed their cart component as whatever they want to call it. And then when we're exposing, the same thing happens. We shard the bundle so that the cart chunk or that cart module and whatever things it depends on is separated from the rest of the bundle. So now I'm able to access those chunks independently. Then the runtime aspect is essentially we output another entry point that I just kind of call the remote entry. And that's basically just a special entry point that that exports an object with get and a net. Get is how you would say, cool, give me something that I'm exposing. So that's accessing the export field. And a net is where we kind of do like a circular, like kind of waterfall series where we go, okay, when I initialize it, I'm going to pass everything that I have to share. I'm going to pass it down into this remote entry, initialize it so it's aware, hey, here's everything that's already available in the system to share. And then it's going to finish its initialization, assign any shared objects that it has onto it, and basically it goes through everybody. So everybody waits for the whole system to initialize, everybody's aware of all the sharing, and in that process, that's when we say, okay, they need Symver 2 for this, they need Symver 1 for that. Is it a singleton? Okay, then we need to find who has the best version for the requirements of everybody connected. And it kind of does all the negotiating for Symver, whatever, at runtime as the system's initializing. And then finally, once everybody's agreed on the versions, we seal the object, which essentially means we do something similar to kind of like object freeze.
Yeah.
Where we say, okay, now you can't mutate the version of React you're going to use from now on because it's now loaded in memory and somebody's utilizing it. So if later on a better version of React comes in, the system can't decide to use that one later because we already have this version of React in flight. So it's kind of like initializing, and then after that, we start getting the components that we want, and then how you see that on the consuming end is it's essentially like a combo of externals plugin and some special module factory stuff we do, where we say, hey, the external is the remote entry file, and then there's a special factory that'll say, hey, call the get method on there. So when it sees the external, it goes, okay, get the remote entry, do the initialization, and then it goes over to like this virtual module that we create on the consumer side when you're importing these non-existent modules. And that one says, okay, after the external has initialized, then call the get method on it and get the module I want and bring it back to me.
Oh,
Man.
And so that whole thing where you're talking about figuring out what versions are needed, that's not part of a build. Like you don't have to rebuild the entire website.
It's all at runtime.
One tiny little thing. It's all at runtime. That's not happening like on request, right? It's happening. How often does that happen?
It happens like in the browser. So as soon as you pull the app up, like before the app like starts rendering the app, it's actually busy negotiating with, because we don't know who's connected to the page at that point, because there's no like server backend, there's no static point. So the remotes can all be dynamic. So imagine if you have like a A/B tests or a dashboard that the user configures. So there's no way for me to say, oh, you're going to be using modules A, B, C, and D. So I can't pre-negotiate that. At least in V1, we couldn't pre-negotiate that. So it was when it gets to the browser, once we start pulling all of them in, they then seal themselves, negotiate who's going to use what, and then the app starts running. And the whole process, though, takes like 45 milliseconds. So it sounds crazy, like a lot of things are happening, but it's extremely optimized.
Wow.
Now, then we brought out V2, and so V2 was essentially, like when I had built V1, the whole idea was, I want to just load chunks from another build that I don't have. And it was very much, I want to solve my problem. And I didn't really think about, because back then, Microfrontends was kind of iframes or just mounting a bunch of apps. So there was not really a good baseline for what's needed. And the stuff didn't really scale. So it was really just, okay, I don't like the problems that I see and I want them to go away. So I just selfishly built the solution that worked for me, which obviously, like, a couple of years on, didn't exactly fit every enterprise need. And also the tech grew a lot more than I had expected. I really just expected me to be able to use it and maybe one or two other companies. And I didn't expect about 45% of the Fortune 50 companies to be running on it. So obviously, like, there was some design oversights back in the day that we ended up correcting with V2. And so initially it was, I just want the chunks from elsewhere. What we had found out, though, is that's not really the major issue. It's not getting the scripts here and you just want to dynamic import things from another build, especially with the introduction of something like, import maps. It was kind of, I would always get the question, well, what's the big difference between, say, import maps and federation? And I'm like, well, with V1, starting to get the itch. I'm like, oh, it's getting a little tight. They're getting a little similar. Federation obviously had the one thing going for it, that it works in any environment. So this isn't just browser. This works in server. This works on native. This works in embedded systems. It works anywhere that you can evaluate JavaScript. So, it was a little bit more flexible, but still, to the, normal user, that's not a big enough wow factor necessarily to say, well, why not just use import maps? So V2 kind of came out to address this, because what I realized is it's not really I want to get chunks from somewhere else, because getting the script is actually the easy part. The thing that we actually want is essentially like express on import. So I want middleware, not just like a map that I can statically say, hey, A is A and B is B, but I need something that's like context based. So if button is being imported by who's the parent. So if header's loading button, maybe it has different rules that need to be applied. Or what happens if it fails? Then I need some kind of error callback, so that isn't in the user's app code where they have to try catch it, because what if they're using import from or require or an uncatchable import? I actually need something very similar to like Express with a request response flow, where I could redirect the request or I could intercept it and I can modify it. And so that's a lot what V2 was around, is like, okay, well, what we thought we needed was just the ability to load chunks from somewhere else. And really what we need is something similar to like a Express-like middleware system on actual dependency and module loading itself. Now, speaking of V2, this is also where it's not just in the browser always, like you were saying, on every request. So with V2, we introduced this manifest protocol, which is essentially like a JSON graph that helps describe what each part has and what they can provide. It's like a JSON version of the JavaScript entry point, a representation of that. So what that means is I don't have to evaluate this, I don't have to initialize the system to figure out what it's going to do. Since now Federation is just an NPM package, we have all the algorithms that do all the share negotiations and that figure everything out at runtime. We now have that just as an NPM package. So what we do at ByteDance is we actually have a server where when we deploy everything, we have something called vmock. So vmock is basically the in-house version of a project called Zephyr Cloud that I'm part of, and they both actually come from the same source, which was my original project called Medusa. And so they were. When I first started working at ByteDance, I went and logged into our CI, and it was I logged into our Git backend, and it was like, oh, hey, welcome back. And I'm like, what do you mean welcome back? This is my first day here. And I go and I check my Git history, and I had commits going back 3 years. And it turned out that because my original Medusa project and a lot of my Federation work, they had just pushed the whole history into their repo. So technically I had been contributing there for a long time.
Way before you even got hired. That's hilarious. It said, welcome back.
So it was pretty funny. And I also saw things in vmock, and I'm like, wait, I recognize the name of that function. And I go and click into it, and I'm like, I remember writing that. That's my typo in that function name. So it was very funny to go and see it. But effectively, if you want to get a better understanding of what vmock is, Zephyr is the outside version that's very similar. And again, they both share the same kind of core. But what vmock is essentially a server backend to help manage and control this. Because cool, you can have all these remotes and all these parts, but the problem you still run into is the scalability issue. You need some intelligence somewhere along the way, because what happens when you've got, in our case, we have over 8 or 9,000 micro-frontends, and some of these things have over 2,000 versions, with maybe over 150 of them active in various products at any given point. So how do you manage who has what, where it is, and then also how do you keep it consistent? So with the JSON protocol, what we can do is, what vmock does is we have an edge worker. So the edge worker receives the JSON manifests of the remotes and then runs the algorithms on the edge worker to create essentially, we call it the module snapshot, which is effectively a lock file. And when that lock file is delivered in the markup somewhere, Federation switches from its non-deterministic mode of, okay, let's see who arrives, and then let's do the circular initialization, negotiate all the versions, figure out who comes from where. That gets turned off, and instead it goes into kind of hydration mode instead of render mode, where it says, obey the snapshot and never change from it. And all the thinking was already done on the server, so just resume what the server was doing and pull the scripts in and start the system. Don't actually think and talk to anybody else. We've already done that for you by just running part of the algorithm back on the server side, so we can deliver that from the edge, which also means anytime we want to redeploy a version or change any part of the system, it's just a change in a SQL table. There is no redeployment, there is no real build, because technically by building it, it's already deployed. And so then it's just a case of, okay, so which part of the kind of the module graph do you want to swap out with what? So production is a SQL row, and that's really it. It's not a zip file that you put on a Lambda or whatever. All that stuff is already deployed somewhere, and the only thing that makes production is the module snapshot vmock return.
It's just a map of, so this is the build, and this is the manifest of all the pieces you need to run your build.
Or it's okay, here's header, and header provides React, and it has this version available, and it exposes A, B, and C. And then here's home app, and home app has React as well. And it also has versions, so on and so forth. And it needs it as a singleton. And so we take those two JSONs and we go, okay, well, the home is going to import A, B, C, D, and E. So we go get me home's manifest and get me A, B, C, D, E's manifest. And then we go generate module snapshot from manifest, and that will output a kind of graph for us. And then we just send that graph down as an edge script or a JSON tag or whatever. And then Federation knows to look for the module snapshot and switch into hydration mode. But essentially, we're running the same thing the browser does, just minus script evaluation.
Jeez.
Freaking evil genius over here.
I know. This is a scale I can't comprehend. I mean, you mentioned how many people are using things like module federation and micro-frontends, but at what point does this scale become necessary for people who are like, what is the threshold there in which you need to start having these issues?
So I would say Kent Dodds had a really good way to put this, because somebody had asked him like, "Hey Kent, what do you think of module federation?" And this was in like one of his tweets where he was saying that he's super non-confrontational or something. And somebody was like, "Okay, well, what do you think of federation?" Because that's usually a very controversial subject. And Kent had the best kind of reply to it. It solves a problem I hope I never have. So that's essentially what it is. If you don't know why you need it, then you probably don't, is the first thing I say. But I would say generally there's two areas where federation comes in really helpful. So the first one is a scale issue. So, okay, the build is just too slow, or, you have these giant merge trains and you're getting bottlenecked here, or maybe your release cycles are really quirky, or you work in an industry like banking or the military, or, other industries like that where getting large bundled releases is really tedious. So decomposing them into smaller, more, liquid parts is very helpful. Also just size of repo, stuff like that. Like we have some repos that are over 100 gigabytes and it takes about 3 minutes to change branches because my SSD, we call that repo the SSD killer. So there's just the thing where the monorepo literally stops functioning at a certain level. Then there's also the other side of it, which is organizational problems. So what happens when teams just don't work well together? Like they just refuse to communicate. Usually you'll see this in like very product-led companies where like engineering is essentially the crown and the product just colors whatever they want. So then you have a lot of dysfunction on the engineering where, hey, you technically could do this with just better engineering processes, but you're not afforded the luxury of it. So the easiest way to make everybody behave together is to split them apart and then just glue it together in the last mile. So those are the kind of the two major categories. Then there's a couple others, like let's say you white label a product. At any size, those are really useful. Or you do a lot of A/B testing in multiple regions. Having to not, code that into, or even if you have like an A/B test team who's separate from your engineering team, usually you would put that in like, Optimizely or Google Tag Manager or something. And that conflicts with like your React code because you're essentially just, patching the DOM on top of it. And that also means that your tag manager is competing for compute with the application. So the revenue funnel is competing with the thing that's measuring the revenue funnel. So in cases like that, regardless of size, it's a lot better when you say, well, what if the tag manager just dispatched something that told Federation what to do? And everything is still managed under a centrally aware system that's prioritizing. Show the user something before you try to measure the monetization of it. There's nothing to monetize on a white screen. So coming to size and scale, though, I would say generally I see it start to become useful with, let's say, I don't know, I've seen them as small as like 5 or 6 parts, but usually the parts we're talking, it's like checkout, community, commerce, and these are like super high risk funnels that you want to just keep separate, but you don't want, like if you're in e-commerce, this is a big one. You don't want that page reload when you jump zones because that has a big revenue hit. Every second that adds on the transition of something equates to X number of millions of dollars. So that ability to have a single page application-like feel without increasing your blast radius, that's also really good. And I've seen those where, okay, well, each team might have like 30 or 40 people under it, but there's maybe 5 teams or 5, director parts, essentially, that split it apart. Usually I say like the golden numbers, probably when you have like 10 to 15 parts is when you start to maybe want to consider it, or, look at your monorepo and compose it really well. On the monorepo end, though, what I usually tell everybody is start with the monorepo until that starts giving you problems. And then just when you build the monorepo, pretend it's federated. So what that essentially means is don't do weird cross-importing in the repo. Like don't have this package depend on that one and you have like 4 circular imports where now you couldn't take this half of the monorepo, split it and put it in a different code base because it's too tangled. If you maintain really good boundaries between that monorepo and just keep a really well-organized one, I found thinking like it's going to be federated and that the code isn't in the same folder actually makes it so that your monorepo will scale longer. And then if you do want to split it up, now you've already primed the system where, okay, well, it still just is the same package import. That just becomes a remote entry, not a symlinked file in the monorepo. And then I can easily switch it over to more at runtime composition from a install link-based composition.
Wow.
So I have in my monorepo, I have like a utils package, and I throw all my like shared utils. The format money is a very simple function that I have in there, and I use that in all of my 3 or 4 different properties. Is that a bad idea for that type of thing, to have a utils package that shares utils? Or how would you publish a utils package in Module Federation?
So for things like that, it usually, for me, it also depends on who owns it, and then like how granular do you want to get? Because granularity can also backfire on you. I'll see a lot of users who are like, oh, well, let's make everything federated, and we'll have like 160 parts to make up, something that doesn't need 160 at runtime parts. So I always think about the balancing act of it. So one is like, well, how often are you deploying those utils? Is it a major friction point? 2, like the rate of change on there, does the API contract potentially break more often? Is it something that maybe is just worth duplicating because it's all right if it drifts a little bit? Now, if it's something, say, like authentication, that's something you couldn't have drift on. So if it was, say, auth utils, I would probably put that as a remote or as a shared module. That way I could say, hey, I can always go and get X version of auth, or if it's like a, kind of the end-facing part, you could expose the authentication handler. So everybody just pulls it in, and then you use something like VMock or Zephyr to say, okay, home app is going to use this version of auth, that one's going to use a different one, and we can roll back or roll forward. So Zephyr is a little faster than VMock, so I'm going to go with the Zephyr number, but it takes about 300 milliseconds to change any part of the system. So roughly 50 more milliseconds than it takes to complete a mouse up, mouse down event, and that's your full deployment, like update to all your users everywhere.
Wow.
So, it kind of depends on, well, where do you need that speed, that agility in there? At the same time, I usually try to say, well, like maybe component library. Okay, depending on how you do it, that might be a good one to put as a shared package, or maybe have like a vendor remote who doesn't expose anything. They just have kind of like the old school vendor bundles. But what if you had a vendor remote where you say, hey, I'm going to have all the packages that generally everybody wants, and then with Federation, I have the whole middleware concept. So I can write a runtime plugin with the resolve share hook and say, hey, if the vendor remote has a version that's viable for you, prefer the shared module from the vendor remote over your own. If not, go into negotiation and find the best option available. So in those kind of cases, I might bubble them up a little differently, so I can just set preferences on where the module comes from, but still have a bit more non-centralized kind of control. So in the case of utils, I would say probably it's really small, and that would probably be something I would just consider like bundling in, because is it worth another network request to like go out and get the extra chunk parts, or is it worth maybe an extra 3 or 4 kilobytes of bloat per bundle that's using it, plus the tree shaking, which thins it down? So you kind of want to balance it out between like what's the necessity of it versus like what's the excessiveness of it.
And then how do you do like a major upgrade of like for example, React? You're moving to React 19. People want to start using React 19 features. How do you do that? You can't ship multiple versions of React, can you?
So you can, but here's the kind of this is the hole that I dug myself into. So when I created Federation, I really wanted the whole, well, I just want to import stuff. Like I don't want mount functions or the kind of LOSA app thing. I didn't want that anymore. I wanted the whole, you shouldn't need to know how to do anything besides say, I want to share React and I want to expose header, and I could just go import, nav team / header, and it's just like an NPM package. That works great, except for in this scenario where it backfires of, but React's a singleton, so how do you upgrade the parts? Because you're using the import from, so it's technically one render tree. Now, if you were to use Federation with like the LOSA kind of architecture or adapter solution where you say, okay, I'm gonna render a div that mounts another React app onto the div, and then we just pass the props and, like component did mount or component will mount, and just, run render or hydrate again when the props change. Then, you can have any amount of versions of React you want, and they will all recycle the minimum number of React major versions available. But if you're doing it in a single render tree where you're import froming everything, you do kind of lose that ability, because it is utilizing the whole single paradigm, and you're technically in a single render tree. So for doing multiple React versions, we did come out with like a framework paradigm or framework capability for federation, which is essentially we provide adapters to allow you to say like take old React to a newer React or React to Vue or, a bunch of other kind of directions for different frameworks. And what we do in there is we actually rebind the routers between them. So your React router will be aware of the Vue router, or the Vue will be aware of the React router. So you can click through it and it routes and behaves like a normal app. But essentially what you're exporting is like create component adapter, consume component adapter. And then that would say, okay, now you can load multiple versions of React, so on and so forth, but you would have to have some paradigm to say, okay, here's a separate tree. So that's generally how we do it when we need to do like upgrades on things. The other nice benefit as well is inside of the Federation runtime plugin, we have a hook called load remote. So what that does is that's like, okay, I'm going to go and get the module I want to load. So if I want header, now I can get header back, but inside of that kind of middleware pipeline, I know who's loading header. So I've done this before where I can go and look ahead and see, okay, the thing I'm pulling in needs React 19, but the consumer is currently using React 17. So when I pull load remote, I can say, all right, but don't just return the factory function, return a new JSX function that says, okay, get their React DOM and return essentially like a proxy React component that mounts that says, okay, parent app, render a div, thing you're importing, mount onto that just rendered div and essentially do it all automatically for you. So you don't need the whole mount adapters that you define in user code, but you could do the same thing in the runtime plugin and say, hey, if the thing coming in needs a different major than the thing it's going to, have the export default be render a div and then have, the thing you just loaded be, okay, put that as JSX on the rendered div you just created. And then you can like magically stitch it together.
And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right.
So who owns the like update process for even like minor deps, not like minor bumps or things like that? Like, is it like the team who owns the chunk or however you refer to it? Like, who owns those choices?
So this is the other thing where a lot of it depends. So so when I was at other companies, I would say the platform team would own certain upgrade phases. So we would own things like the application shell. So we had a federated app shell as well. So when you develop locally, you pull the app shell off of stage or production, and we encapsulate localhost in production's app shell. So you're technically developing as if you were using production's code, and your local app is essentially just like a zombie application with nothing. And all the providers, all the auth, everything like that is coming from stage or prod. And then when you deploy it, we reverse the process, and we say, okay, now the page is federated into the shell, not the shell is federated around the page. And so we can kind of reverse that. So then the platform team would own the wrapping layers to ensure that telemetry was there, that when we update the telemetry, we would be the ones who would, push the versions to all the product teams and so on. At ByteDance, a lot of this is controlled by the product team. So the product team will say, all right, maybe if I want to update, say, button or whatever, just so that we kind of have that safety, because again, you don't want things changing without your notice unless you do. So generally we'll say, okay, the product team owns the lock file or the VMock, the VMock dashboard, and then I can go in there and say request an update to it. But I also have like Chrome DevTools, which allows QA to assume a certain module snapshot and test it without needing to go in and change VMock or change production or do anything. So any environment can be any environment you want. You can use production as localhost and develop locally, telling the Chrome DevTools, use my localhost remote and replace production, and we can turn hot module reloading on in production, so every time you hit save, it HMRs the app just like in development. But generally, we say the log file is owned by the product team that owns it, and when we need to contribute to it, we can either request the update happen or whatever. Now, again, this can also come down to just the dynamics between the team, because maybe it's something like header, and it's super generic, there's nothing that's really going to break in there, and maybe the product team doesn't want the overhead of having to approve things or whatever, then the teams can agree that, hey, we just want the latest of header. Or what they do in VMock is they would say header star, which just means get the latest. So then every time header pushes out a new one, it's instantly updated. But they can control the rules on, where do they want the governance on their own product and what's going into it versus where do they want, less restrictions on what's flowing in and out.
Man. And do you ever see people use multiple frameworks with this as well? Because often I talk to, specifically at conferences, always people that work at banks or insurance. And they say, we have 5,000 devs and 14 Angular apps and 20 React apps and 3 Vue apps. And it's just like, sometimes you need to share stuff. How do you approach that?
So this also works with multiple frameworks. This is one of the reasons we brought out that framework bridge system. So essentially, if you have a Vue app, you can mount it and the consuming person treats it like React. They're using JSX. They have no idea they're talking to a Vue app. So the consumer receives it in the format that their application is in, regardless of what the other framework is. The thing I don't like about the multi-framework approach, and this is one of the reasons that Microfrontends was like where it got popular, is, you could use any framework you want anywhere. Yeah. And that's like a terrible idea because, your devs might love it, but your devs aren't the revenue funnel. So for me, it's like, okay, well, now I'm loading multiple frameworks which have weight on them. So you can use it for that, and a lot do. It's also really good for like transitionary periods. So, if I'm going from like Angular to React, boom, Federation lets me link all the parts together and it behaves like one. But generally, I try to say you want to try to unify on your framework just so that, one, talent pool dilution. If you have to maintain 2 or 3 component libraries that all look the same but are in different like formats, you just have to hire 3x and develop 3x on it. So generally, I like to say, try to keep it all in one framework because you have more reusable parts. It's lighter to load. And I think that's what gave Microfrontend a bad name, was the Wild West of, hey, we can just use anything anywhere and it all will work, which, it will, but at what cost? So generally, I don't like that approach. Like at ByteDance, everything is essentially in React, and that's how we use it because that gives us the most like flexibility and interchange between any part of the company. But we are also very big on unified architecture. The sum of parts makes a product, and everything there is kind of geared for how fast can we get stuff out and, how efficiently can we? If we can bring down the cost of R&D, we can develop a whole lot more, see what happens without it becoming without a bad idea being a negative thing. Build 20 apps, and if it takes you 3 months, who cares if one of them is successful?
At ByteDance, when you're writing React, I think I saw somewhere you have a meta framework that you use. Is that true?
So we have 2 meta frameworks. So the one that we had, the big one is ModernJS. And so this was a problem that we had seen with ModernJS. It didn't get a very welcoming launch. And so I had to translate the posts from Chinese when I read about why it wasn't well received from somebody who read it. But essentially, the reason was it's like, this looks super great if you need to do anything in your ByteDance, which was kind of true. Like, it was essentially this massive, if you go to ModernJS doc, I think it's getting better now as we've reduced the scope of it. But back when I first got there, I could read the docs for 10 minutes and be like, this is what I need. But what does it do? Because it was ModernJS doc, which was like static doc gen. It was Modern Module, which was a meta framework for authoring NPM packages. And it was the Modern Framework. So you go there to read the docs and you aren't 100% sure what it does within the first 5 minutes. You just know it does a lot of things. So what we'd actually ended up doing though is now Modern Doc is actually Rspress, which is our Rspack based, static site generation, all of our Rspack Federation, all of our documentation sites are all just Rspress. So we split that part out of ModernJS and said, hey, same idea, but having a one-fits-all is just too intimidating and too, polluting. So while it works great for unified architecture, there's that lack of composition, which just adds to confusion about what the point of the product is. So we made Rspress, which was essentially the same idea, just repackaged and reduced the scope out of ModernJS. And then RSlib, which is also the same thing as Modern Module. It's a meta framework designed for authoring NPM packages. And now that's got its own site, its own everything, and it's completely separate from ModernJS, but it's effectively almost the same architecture, just refreshed onto a Rust ecosystem. So ModernJS is the web framework, but highly composable. So a big challenge that we had for us was, again, we need to support all sorts of weird environments, like WeChat things and native apps and all sorts of stuff. And so ModernJS is actually just Remix-based application. But Remix isn't a meta framework. Remix is really, and this is what they've all said, Remix is just a library. It's React Router with a render handler. Then they added a Vite plugin because users want some meta framework preset. Yeah. So the Vite plugin is what takes it from library to meta framework. So essentially what we wanted was, okay, let's get like a Next.js kind of equivalent of what the Remix library can provide. And then that became ModernJS. One of the big challenges that we had though is like Remix at the time was very SSR heavy. And we don't have enough compute to handle the traffic to SSR everything. So, because we've got, I don't know, like a couple billion users. And if you have to SSR every one, you will, especially with highly personalized, ever-changing content, you'll effectively exhaust an AWS region very easily. So we'll run out of Lambdas before we can fulfill the spike in demand at any given point. So we needed mechanisms that we could control it to say, well, if I don't need to SSR this part or this route, I shouldn't have to. Or if I need to SSR it, if the Lambda doesn't reply within X milliseconds, it should be able to skip the server render, and then the edge should be able to send back the CSR app, and it'll be able to restore itself in the client. So ModernJS kind of handles a lot of those other mechanics for us, but it's effectively, very similar to Remix, similar API, stuff like that, but with, micro-frontend support kind of baked into it for us. All the parts like that. So virtually every app that I see or work on is ModernJS based. Now in China, we have another app called Pace, which is essentially like if you took RSC, Astro's server islands, PPR, like if you took all the fancy acronyms that Astro and Vercel have kind of created, it's effectively all of those things combined, but based on Remix, and it's super lightweight. Like its CLI is literally run this long bash shell command that like makes directories and like writes it's like a one-liner bash that's like that big, and it just stencils out the app. But Pace is really, really cool. It's like probably our more modernized, like super light, adaptable kind of response to server islands, RSC, and so on. But that's primarily only used on like Douyin, on the Douyin web, which is the homepage for the Chinese TikTok. And I think a lot of that was really just proving ground for, okay, like, how would RSC work? Like, what do we want to do with it? And then now that we've like fiddled with that for about a year, we're looking at, okay, now we'll pull those features back into ModernJS. So ModernJS is essentially like where all the big stuff happens, that we have maybe 2 or 3 other web frameworks that aren't open sourced, where like faster iteration or experimentation happens just because it's cheaper to write a new framework than absorb the risk of changing the one that we know works.
Another thing I want to ask you about, because I tried for a year to find this out, and I did finally get the answer, but I'm curious if you know about it, is ByteDance has its own JavaScript runtime. And for the longest time, I could not figure out, I was asking everyone, like, could somebody please tell me what they're using this for? And then finally I found some posts in Chinese, and I translated it, and I found the author of it, and he tweeted a couple lines back at me. But are you aware of that at all?
There's a few places that it's used. So the one is, I think we have something called, I can't remember the name. I think it's Byte Cloud or something like that. But essentially we have our own like edge runtime. So I think it's more popular in Asia, but essentially kind of like how Vercel has whatever they've got, and Cloudflare has, what's theirs? Workerd.
Workers.
We've also, we've got our own edge runtime. And then we also have something basically similar to Hermes, which is in React Native. We've got like similar to Hermes kind of makeup as well for, doing whatever like Hermes would do as well. The main differences, though, I would say are we've pushed a lot for web standards, so making sure it's actually compliant with like all the web specifications. Hermes, I know, doesn't have full standards in their APIs. And then the other thing that we also have is ours supports the NAPI APIs. So you can use this tiny runtime, but it's NAPI compatible, uses the NAPI API, or can use the NAPI APIs. And I think we can compile it down to WebAssembly and, all the other kind of things that are useful for it. But effectively, like it's, those are the couple areas that I know it's utilized in.
Awesome. And for listeners, that NAPI is the Node API for basically kicking out to native APIs that may sit on your user's machine.
Yeah, this is like how Rspack is really quick. So Rspack is fast because it uses Nappy, and Nappy is where we can bind to, like, this is, I think, a challenge, like with, say, WebAssembly-based stuff, is you lose a lot of the speed building it in that way, but if you don't target like WebAssembly, what you're usually targeting is the Nappy APIs that you can use. I know Nappy RS now has WebAssembly targets, so it's a lot more interchangeable. But yeah, essentially that lets you fast access to the C layer, and you can skip the JS communications for various access.
That's awesome. So one thing we didn't even talk about at all, and we'll have to have you come back at some point, is like Rspack entirely, right? Like, so part of the problem at ByteDance was that building was very slow, right? Maybe you can just give us a little teaser. Maybe people can watch the conference talk, but build times were very slow, and you needed to speed that up.
It's really hard now in like the modern times to get the full benchmarks, because like a lot of areas are using ZMock or use Federation. So I had the business measurements on Federation, and this was still when it was Webpack based. So we haven't like reconsolidated it with now Rust plus that. But I know for any product team that used Federation, you would see a 300% increase in product output. So it's a little different from engineering output, which means, I can spin the wheels in the mud quicker, but product output is more like, meaningful things that enter the product, that have like a positive impact. So like actual feature release. So with Federation, we had seen about a 300% increase. And so part of this was smaller shards, faster builds. But the other part was, again, just that ability to interchange it and kind of avoid the double deploy scenario. But now still, there's lots of aspects where there were still challenges. So, one of the other big areas was really just builds in general. So what we had seen is for any build or for any CI process that takes 35 minutes or over, the mean time to merge is about 1,600 minutes. So it was kind of also regardless of size. Obviously, slower the build, the bigger the code base. That does skew a little bit. But when we introduced like Rust tooling, that obviously helped kind of normalize our hypothesis here. But essentially what we saw is if a build is under 5 minutes, the merge latency is about 20 minutes, regardless of the size of the application or anything. If the build is within 5 to 10 minutes, or if the CI is within 5 to 10 minutes, the merge latency is roughly about 3 hours. Now, if it's, say, 30 seconds, it's still 20 minutes. And if it's 4 minutes and 30 seconds, it's still 20 minutes. So there was virtually no improvement beyond getting into the golden zone. And generally, you're not going to do a whole lot of merges within 20 minutes just because human processes. So generally, what we try to target is the 5 to 10 minute range for CI to complete. And that gives us a realistic, cool, it's done, people can preview it, and generally, within 3 hours, that merge will happen. But a major constraint of this really became, like how much latency are we losing in the product because the build takes 30 minutes, and how long are you staring at it before you change another branch and you go and do something else, or it's the end of the day, or you forget about it and you get sidetracked, and now that product velocity starts to tank. So getting that curve down to the habitable zone of, 5 to 10 minutes, I think it had something like just on a single repo, I did the math on it, but on a single repo that would churn from taking it from like a 30-minute build down to that zone, it's something like 1 million hours in latency a year recovered for just one product. And that's just one of the repos among thousands of them. So a huge amount of like actual product value time pushed back in, more iterations, more meaningful iterations. The actual reason that we built Rspack, yes, builds were slow and we saw this latency curve in here, but one of the primary reasons for Rspack was actually cloud costs. That was the biggest cost center, was the cloud. So, really? Because I think also labor's not quite as premium as it is here in the US. So manpower is not the major burn, it's compute. So the primary reason for Rspack was to reduce the cost of compute. So what we had seen when we switched everything over to Rspack was across the board 80% reduction in cloud cost, which was huge. On top of that as well, we'd also seen like bandwidth egress costs go down because we've done a lot of work to improve tree shaking and code splitting and how modules are optimized and where the chokes go. Outside user had told us that they'd seen about I think it was like a $10 million a month reduction in egress costs just by taking what they had currently, changing the package from Webpack to Rspack, and then switching out a couple of the loaders like we suggest. And other than that, it was, just a lift and shift. Took them about 2 hours, and you're looking at $10 million in egress cost.
Being responsible for something like that is pretty amazing. Like even being on a team to cause that much of a shift in reduction of costs is out of the scope of my brain power here. It's pretty amazing. Yeah.
We had the folks on from Amazon LLRT, and they're explaining that as well. They're like, simply if we can cut 30% off of how some specific things take to run, it might just be 30 milliseconds, but compound that by how often it's run, it's a massive savings.
Yeah. I think like our own savings just on like from our own like measurements and stuff like that internally, Rspack's ROI has been in the hundreds of millions of dollars for us ourselves in utilizing it. And I mean, given how much it costs to develop, this was another crazy thing is like the problem was so expensive that the cheapest solution was to write a new bundler from scratch. And that was it was cheaper than migrating to a different build solution. Because again, we've got like 10,000, 20,000 repos. So we had tried to I think early on there was, okay, maybe we look at Vite and we see, hey, maybe Vite it's getting popular and all of that. And so one was the cost of just moving everything, cost of change management was massive. It would have taken, a huge amount just to switch everything over. Mm-hmm. On top of that, build is already the biggest on-call area. Now you're going to swap it out with a different build. And on top of that, we also had things that were non-negotiable. I know they're fixing it now with roll down, but at the time it was the whole unbundled problem. Mm-hmm. So unbundled, for us anyway, if you have Chrome extensions on the browser or you have anything in the dev workflow where maybe they have their cache still churned on or churned off, usually you'll see habitually, that could lead to minutes to hot reload the page because the network requests have to go down again. So technically some of that is user error, but the problem is again, on-call pressure and the fact that it doesn't just magically do it. And then I think this is more issues with, ES build and a couple others, but the chunk fidelity. Not being able to chunk things really well sounds really silly, but when you start looking at the revenue pipeline on the larger end, artifact stability and integrity and the ability to chunk things correctly, not make it too granular, not make it too large, became a really major concern. And ultimately, the cheapest option was to just rewrite Webpack and Rust. Now, granted, there were 4 other bundlers we wrote in between and architectures we wrote. It wasn't let's go and make Webpack and Rust. That was the last attempt after several other design attempts before we kind of realized, look, there's just nothing out here that has what we need it to do. And ultimately, everything else we tried was a case of everything that a bundler lacks that we would require. We just found out we're ending up just writing Webpack again, minus the test, minus the stability, minus the ecosystem, to the point where it's okay, well, if we need so much of these Webpack type capabilities that we know have worked for the past decade, it's probably just cheaper to just port Webpack to Rust. And then on the back end of that, we can look at speeding it up, getting rid of things that we don't like, but starting with a guaranteed, we know it works, one-to-one match. Anything that we change from there, we know we have 60,000 unit tests backing it that it always works. And it's a lot cheaper to just, on the tail end, decide to make changes afterwards once we know we have an exact business drop-in for it.
Yeah, man. And the one thing I thought, I know we're getting to the end of the hour and I'll wrap it up soon, but one cool thing I wanted to say is that you obviously built Rspack and then also made the API work with Webpack. But one kind of interesting thing you said is that's not the only way that we could surface the technology behind this, because if you like the way Vite works, maybe we could build something like that, or the engine of this thing could be surfaced in other ways.
So this is a lot of hate that Webpack gets, unfortunately, is a lot of it I find is people just don't like how you configure it.
Yep.
That's it. And Vite, changed the game in terms of simplicity and streamlining the user land overhead massively. And so, we have something called RS build, which is essentially the Vite style API, super slim, no loader plugin config, totally different config layer. And it's just a build tool, similar to how Vite is a wrapper around rollup and ESBuild. RSBuild is a wrapper around Rspack. So it gives you this really streamlined, if you want React, there's a React plugin that sets up all 6 pieces that you want. So much smaller surface area to chain things that you want together. It has an environment API as well, similar to Vite's, all of that. So we have like those layers to separate you from the underlying horsepower of the tool, which framework authors probably still want. End users want that simplicity. But a lot of people go, this is just a Webpack port. It's whatever preconceived notions you have. But the main reason that we had chosen Rspack, there's two sides to it. So one is, there's a plugin API, and having all of that for free and work right out the box obviously saves time, saves money, gives us an ecosystem from day zero. But the second aspect of Webpack is its actual architecture internally. And so this is where we ran into the most problems developing bundlers. Is building a bundler is relatively easy and cheap to do. Designing it and architecting it is not. And because Rspack is in Rust, the nice thing here is the Webpack part of it that we think of, Webpack, I don't like that. Okay, what you're talking about is the bindings. Because this is a binary, so technically there's no deep-seated or connected things. The bindings happen to look like Webpack's front-facing API and config, but the back end of Rspack is using Webpack's architecture, how they designed their actual compiler to work. And the compiler architecture is totally separate from the user plugins, the APIs, the config layers. All of that just happens to be a style. So we did this, we're working on releasing in the next year the Rspack SDK, which is essentially saying, okay, if you want to build a custom bundler, do you want to have to build your own module graph and chunk graph and compiler class and all these parts again? Probably not. So we're going to release an SDK where you could say, all right, well, here's all the parts, and you can make any bundler that you want. And those bundlers won't have any kind of, connotation to Webpack's design or anything. Purely, it's just, here are the parts, and you can build it. And if you create a certain set of bindings, it happens to look like Webpack. So that architecture, we have a project that we've been experimenting with called Unpack. It'll be under Hardfist. I think his GitHub handle is Hardfist, so it'll be like Hardfist/Unpack. Yeah, and essentially it's using unplugin as the bindings, as the Rust bindings. So instead of using like Webpack's bindings or whatever, we said, well, what if we took Rspack's architecture or the Webpack style compiler architecture, but we used unplugin's bindings, its API. So instead of using Webpack's one, it's just whatever unplugin does, that's the bundler's API. And in there, we kind of noted, okay, it's about 100 times faster than Rspack, but it has 10% of the power of it. So obviously, again, what makes it powerful, what makes it slow, all of that is really just, okay, well, when you use Webpack, for example, it's applying like 100 plugins for you. When you put your little Webpack config in there, when you say like target node, that's a node target plugin and a common JS chunk format plugin and like 6 other plugins that make this thing go into node JS output mode. So when you slim all of that down, you go, okay, well, here's a compiler class, and if you want to chain things onto it, then you can. Obviously, you can make it super fast or simplify the API greatly, but in doing so, you might lose some of the functionality that it can have just because user API is more limited, or we're just not adding as much on there to give it that one-for-one experience to Webpack. But at the same time, it does kind of prove out that, hey, the only thing that makes it Webpack is the bindings file. So in V2, what we're looking at is, okay, so what happens if we potentially look at, let's maybe replace a couple hooks that we know are slow or we know are burdensome. Maybe we get rid of those plugin hooks or deprecate them and we bring in something new that can do this in a better format. Or, what if we start changing the user API a little bit and maybe offer something that's a bit more streamlined? Or what if we use it in tandem with something like RSBuild, where we can already say, hey, we can simplify all of this and we can make the back end of the compiler more oriented to dealing with the complex tasks. And we say, hey, the end user side, your main point of use is through Rsbuild, which is this lightweight, streamlined tool. But yeah, essentially, there's no real connection between the Webpack architecture and the Webpack config and plugin API. And for Rspack, the only real connection there is the binding.
Man,
I just had my mind absolutely blown for an hour straight. I could probably go on forever, but we will start to wrap it up there. Scott, do you have anything to add here?
I have questions, but I'm sure they would invoke another 30 minutes of discussion here. But no, I have nothing else to add. Zach, this has been amazing. It's been mind-blowing talking to you. You've made sense of so many things that have big old question marks in my head for so long. So I really appreciate the time you've taken to break all this down for us. It's been really amazing.
Yeah, thank you for having me. There is one other thing I wanted to add that we never covered on the federation side, which was just, so in V2, while we came out with the whole middleware side of things, there are some other major features that we had brought out, which I would say these are probably some of the killer aspects that you don't find with the other solutions. One is that we have actual hot module reloading available, which, you can turn, and it works through a Chrome extension. So even if you're in like production, you can hit the switch on the Chrome extension, and because production is powered by federation, we can say, oh, well, React is now the development version of React, and we can source that from a different location. And we have a plugin built into the system that tells it, hey, if the Chrome extension tells you to use the dev React, you're going to source the dev React from the Chrome extension instead. So it allows you to switch it on and off without actually any build complexity. One of the other major things, though, that I didn't cover is that we support remote types. So this has been probably a major issue with any distributed system, is you lose the ability of type safety. And so this is something that Federation does support, is hot reloadable types and remote types. So if you deploy something to stage or production or whatever, when you link to that manifest, in that manifest, we have a piece of metadata that says, hey, here's where the types bundle is. And when the compiler starts up, it will search through the manifest and it will resynchronize the types and extract them on your disk for that version you're using. And then obviously, like if, say, you push new version to prod or stage and the contracts change, the next time you run a build, your types will also be updated and you'll get a type validation error, whatever type error you get to say, hey, the contracts don't work anymore. So that's like probably one of the coolest features that I've seen come out there. One other thing that's really neat with the types, because we got this a lot, which was, well, how do you deal with it when it's not statically analyzable? Like what happens when you're using our runtime? Since Federation is not bound to a bundler anymore, there's a plugin that helps prepare your chunks. And then there's the runtime that does all the orchestration of it. And the two aren't necessarily mutually exclusive. Like you can use the runtime without a build plugin, no problem. So, you can consume it anywhere. But a lot of people also use the runtime when, say, it's super dynamic, like the CD or, a database controls which remotes are going to load in which slots on the app. So you don't know what goes where, or you're using state to kind of set the import that you want. Inside of there, we also have, when the dev server's running, our type engine runs in the background, and the browser will actually send the at runtime discovered, because we can't analyze it statically, but when you go, hey, load remote var/var, we'll go, oh, they're asking for home/checkout, and we'll actually tell the type engine, hey, here's another type that we located that could only be found in the browser, and we post that back to the type engine, and it will synchronize dynamic types as well. So even when you can't statically analyze something, the browser is informing it of any unknowns that couldn't be found during compile.
Yeah.
That's sick. Man, so many hard problems to solve, and it's really fun. Cool. Wow. Well, thank you so much for all your time. The last thing we'll ask you is what you want to plug to the audience. Do you have anything else other than the stuff you just talked about all day today?
Okay, so one, definitely if you're into micro-frontends or anything like that, check out zephyrcloud.io. That's kind of the equivalent of VMock for outside. So if you're looking for stuff to manage, and it's not just, manage the assets, but it's like Kubernetes for the front end. It's your infra, your cloud, no markup, and it just helps you manage your cloud and where things go. And it's got stuff like, I think the coolest thing we saw was they pushed a bad deploy deliberately to a native app, to a backend service, and to the front end. And within 1 second, the system automatically recovered from 3 critical failures throughout all 3 applications. They were all running on Federation, and it was down for 1 second and brought back up autonomously. So really cool thing to definitely check out. Another one that we've been cooking up at ByteDance has been Midscene.js. Definitely check it out. It's essentially ChatGPT meets end-to-end testing and browser automation. We have a really cool Chrome extension, which I've used to help manage my stock portfolio and stuff, where I can just tell it, hey, go do this and click around here, and I hit play, and it takes over the browser and does some stuff. But there's actually a library for it too to do all of your end-to-end testing. That's definitely another cool one that's under our web infra hood at the moment. That's definitely worth checking out.
So that's like a vision model, right? I was just telling Scott about this. I was like, there's models now that can look at something and figure out what buttons and actions are.
Yeah, and it's super reliable. So it's got like a whole inspector that comes up, but essentially it uses machine vision, then it tags the page and figures out like what each aspect is, and then it interprets your prompt and goes, okay, cool, then I should be using this tag for this part of the page. But I've used it to like open and close positions, like, hey, every morning run a cron job that goes, clicks through each stock in the list. If the stock has spiked, like sometimes pre-trading, they skyrocket. So I say, hey, if it's pre-trading window and the thing has risen by X amount, then I want you to step 1, click on sell position. Steps 2, sell 50% of the position. Then click review order and confirm, and run that cron job every morning before I get up to check for any spikes and sell in and out. So I obviously use it for something else, but it's designed for end-to-end test assertion with like Playwright or something like that.
This is amazing. I've never seen this before, and I'm going to be spending some time with it today. So thank you for that.
Yeah, it's got lots of cool uses.
My nefarious scraping brain just started pinging, being like, oh.
Yes, right. Yeah, your scraping brain.
Cool. Awesome. Well, thank you so much. Appreciate all this. We'll have you back on at some point. You're a fount of information. And we'll catch you next time.
All right. Thanks for having me. Good to meet you all.